ask that we have to him, the help that we're able to lend each other. We ask you to please bless us that we can prepare for our test and we can learn as quickly as possible the things we are struggling with. And we say these things in the name of thy Son, Jesus Christ. Amen.
Amen. Okay.
Well, I guess I'll take number 2.
Okay.
Okay, for each of the next 4 questions, identify the one hypothesis test that is most appropriate to the given situation. In an article in the Journal of Small Business Management, successful startup businesses in the United States and Korea were compared. One set of data compared educational level of people who manage successful startup companies in the United States and Korea. You want to determine if the education level of managers of successful startup companies is independent of the country they are from the United States and Korea. Which hypothesis test would be most appropriate for this analysis? Can someone explain the difference between one sample z-test and one sample t-test? Does anyone know?
I just gotta find my paper.
No.
The only thing I have is the one sample. The test is it's quantitative, and it's when you know the standard that little round circle thingy, Delmer.
Mm-hmm.
That's when you know that is the one. And the t-test is when it's unknown.
Okay. I was thinking it would be independent sample t-test because it's quantitative, not qualitative, right? And it's just 2 independent samples.
So are they asking if it's categorical or is it quantitative?
I think it's quantitative, not categorical, because the scores. Well, actually, you're right. How do you determine if it's successful? It's education. You would determine success by dollars, by money. So quantitative.
Yeah.
So independent sample t-test.
Makes sense to me.
All right.
But isn't it 2 different companies?
Yeah, but the companies are all independent of each other. So it wouldn't be paired samples, it'd be independent samples, I think.
Independent sample t-test, is that what you said?
Yeah.
Okay. I thought it was test of 2 proportions.
I don't think it's test of 2 proportions because we think it's quantitative, not categorical.
Yeah, and I think that's why I thought it was the test was because I thought it was.
Oh, okay. Gotcha.
Okay. Ross, here we go.
Yeah, I'll do number 3. A human resources manager reported data from a recent involuntary reduction in force at her company. You are an attorney and want to determine if age discrimination was a factor. It is illegal to discriminate against employees because of age. The company reported the number of employees in 2 groups, 40 years old or younger and over 40 years old. They also reported the number of employees in each group who were terminated. You want to determine if both age groups were treated equally. Which hypothesis test would be most appropriate for this analysis? So that one would be categorical, wouldn't it?
I think so. Because I just imagine a pie chart, and we're going to split it in that pie chart between the two age groups, two
Yeah.
age categories.
Um, I'm thinking test of two proportions.
I think so too, because we're comparing the two proportions, yeah.
Yeah, I think so.
Okay. I did this earlier and I'm thinking totally different. So I'm gonna go with what you guys, because you guys are usually right and I'm not.
I don't know. At least me.
Yeah, these ones where it asks what test it is, like, it always confuses me.
Yeah,
Yeah.
these ones get me every time.
Yeah, I agree. Okay, I'll do the next one. A survey was conducted by a group of state lotteries. A random sample of 2,406 adults completed the survey. Total of 248 were classified as heavy players. Of these, 152 were male. You want to determine if the proportion of male heavy lottery players is different than the proportion of males in the population, which is 48.5%. Which hypothesis test would be most appropriate for this analysis? So I'm saying I would believe it's quantitative. And I'm thinking would it be paired? Because it's comparing the heavy to the regular?
I got a test of one proportion.
You tested one, so you think it's categorical?
I do, because it's like 152 of 248. You know, it's like it's taking those percentages, and then you've got the population, and then it says the proportion of males of in the population is 48.5%, and whenever it starts doing proportion, then we go with the test of proportions.
Oh, okay. So that's
Yeah,
That's what I
I
think,
thought
at
it
least.
was test of one proportion too.
so that's kind of like a clue in the test when I see that.
Yeah, so if it says proportion, or if it says, 152 of 248, that's a proportion and more categorical, I guess. So there's only one proportion that we're comparing here, so I got test of one proportion. Like in the last one, there was two proportions that we were comparing to each other,
Right.
and so I got the test of two proportions for that one.
Okay. That makes sense. Okay.
It's right, because it makes sense to me, at least. We'll find out. My turn. A student project compared the effectiveness of two different combination locks. One of the locks turned devices first, and the other lock turned. Okay, I'm sorry. One of the locks turned clockwise first, and the other turned counterclockwise first. They asked 25 students to participate in the study. Each student was given a combination to each lock and asked to open the locks. The time it took to open each lock was recorded. They want to determine if one of the locks is easier to open. Which hypothesis test would be most appropriate for this analysis? I would do the paired sample t-test.
Because that is quantitative.
Yeah, we're comparing times, and each time is paired because there's one person doing both, so they're paired together.
Gotcha.
Okay. Yeah, these get me all the time.
Me too.
Yeah.
It's a good thing they make us practice a lot, because otherwise I'd be like,
Yeah.
sorry.
Yeah, and Sister Lemon has some of these on her exam review that she goes over with the words and stuff.
I should watch that.
Mhm. For the next 3 questions, identify the one confidence interval that is most appropriate for the given situation. A bank employs 2 appraisers when approving borrowers for mortgages. It is imperative that the appraisers value the same types of properties consistently. To make sure this is the case, the bank evaluates 6 properties that both appraisers had recently valued. Which confidence interval would be most appropriate for this study? Um, I think that would be independent sample T confidence interval.
It wouldn't be the paired because they're.
I don't think it's either. Because, I don't know.
It's 2 appraisers. So they're doing the same property. And they're just looking at the. I don't know. That's why I thought it was paired. I don't know.
Because I was thinking the 6 properties are independent of each other.
I was thinking there's the appraiser's value as like the population, and then they're comparing it when they go back and double check it as like what's the chance that this is going to be different from the population mean. Oh, I don't know, guys. Well,
Well,
guessing game.
We'll go with what Ross says.
Awesome. Which one did you say, Ross? The pair or independent?
Independent.
Okay.
Good thing we have another try.
That's true.
Do we have another try on this one? Yes.
Yes.
Okay. In a Wall Street Journal on satisfaction with career paths, percentage of psychology majors reporting they were satisfied with their career paths were reported. The same data was also reported for accounting majors. You decide to construct a 95% confidence interval to see if the observed differences is significant. Which confidence interval would be most appropriate for this study? Once again, I took an educated guess. So, where am I at? I thought it was paired because they're comparing one to the other, but yet they're not paired because they're not like a twin.
They're not connected in any way.
Right, so it's not paired. So it's independent.
That's what I think. But if we put independent on this one, then the last one probably wasn't independent.
That's what I'm thinking.
But I'm pretty sure that this one, number 7, is independent. So should we go back and look at 6?
Yeah.
Yeah.
What was option number 2? Paired?
That's what I thought, but.
Okay, let's try paired then. All right. Number 8. Yum. Double stuffed Oreo cookies are supposed to have twice the filling of regular Oreo cookies. You and some friends decide that you want to know if the true assertion by the company, if that is a true assertion by the company who makes them. You take a sample of 55 double stuffed Oreo cookies and measure the amount of filling in each one. You need to construct a confidence interval to estimate the true mean filling amount of double stuffed Oreos in order to compare it with the filling in regular Oreos. Which confidence interval would be most appropriate for the study? Oh. These ones are hard.
Yeah, they are.
Okay. It's not paired.
But there's two of them, so it's the other two proportions.
Would it be a proportion or would it be a... I don't think it's a proportion, is it?
I don't think so.
It'd have to be. Well, there's two of them. We know they're comparing the two. So is it paired samples?
No, not paired.
Because they're both different Oreos.
But choosing one Oreo doesn't determine the normal Oreo. So it wouldn't be paired. Would it be possibly a one sample? Because...
But it does say the filling in a regular Oreo compared to double stuff.
Did it say where you need to construct? But we don't sample normal Oreos, just the double stuffed Oreos. So would it be a one sample?
Okay, I see what you're saying.
Yeah, I think so.
And would it be T or Z confidence interval?
We don't know the mean, do we?
No.
So it's probably the T.
T. Okay. Yeah, because I'm sure what they do is they compare it to how much is in a normal Oreo, which they probably know the mean of.
Yeah.
Yeah. So it's a one sample.
And the T confidence interval?
Yeah, I think so.
That's what I would have guessed.
Oh boy, only like 50 more to go, guys.
Oh, great.
If my computer's close to dead, if it dies, I'm gonna jump on my husband's. It might take me a minute, just so you know.
Okay. All right, question 9. Which one of the following best defines the notion of the significance level of a hypothesis test? I think it's the first one.
Me too.
Do you think it's the first one?
Yeah.
What did you think it was, Catherine?
The third one? Because the probability of rejecting it is that's the A, right? So the next one says the p-value.
The confidence, here's how I understand the confidence interval. The confidence interval is there's 95% chance that the true mean is between this point and this point.
Okay.
Probability of rejecting. So I think if anything, it would be the probability of rejecting the null hypothesis. Actually, I don't think it has anything to do with the probability of rejecting. Oh, let's see. The probability of observing.
Because the p-value is one of them, right? Is rejecting. Because if p is low, you reject, right? I think that's probably right.
Oh wait, you're right, Catherine. The significance level is the probability of rejecting the null hypothesis when it's true. For example, a significance level of 0.05 indicates a 0.0 or a 5% risk of concluding that a difference exists when there is no actual difference. So, yeah, so the probability of rejecting the null hypothesis. Did we all get that?
Yeah, the third one.
Mm-hmm.
Okay, number 10, which one of the following best defines the notion of the p-value of a hypothesis test? And I believe that's the third one. Probability observed, the same one we thought was the other one?
Yes,
This one.
yes. Yep.
That's right.
You're killing it, Catherine.
Oh, at least I got 2 of them. My brain must be not too foggy.
Oh, bless your heart. Okay, number 11. Suppose you create a 95% confidence interval. Oh, did you start recording this? No, we don't have to record this one, right?
I am, just if anyone wants it, to go back
Okay.
to get the answers.
Yeah, maybe we should send it to Mike to help him out.
Okay, yeah, I'm recording it.
Awesome. Suppose you create a 95% confidence interval for a mean. You get 10 and 20. You've been told to report this by saying something like, we are 95% confident that the true mean is between 10 and 20. Exactly what does this mean? Well, I feel like that was a really good self-explanatory way to say it, but there is a 95% chance that the true mean is between 10 and 20. The last one.
I don't think we use chance in those, though, do we? I thought it was the confidence. I don't know. Because I think I keep hearing her say don't use the word chance in there.
Oh, is it 95% of sample means are between 10 and 20?
That's the one I was thinking.
Or actually, 95% of the data is between 10 and 20.
I don't know. I was thinking the one you didn't say, 95% all 95 actually contain the true mean. Because it says we are 95 confident up on top. I'm just going by the same words. Thinking that makes sense to me. I think I read that somewhere.
You know, why don't we just all do something different? I don't know. I think it's the 95% of the data is between 10 and 20.
And I thought it was that first one, the sample mean.
I know I wrote it down, but I can't.
Let's all just put different ones, and then we're all going to be right. Or someone's going to be right.
Yeah.
Not a bad. Okay, let's all put different ones.
Now I might put the third one.
Okay.
I just found it said avoid these types of statements. 90% of all. There is a 90% chance. 90% of all data. 90% of the sample mean.
Oh, you're right. Oh, so it can't be 95% of the sample mean. Right?
Yeah, that's what I wrote down last time when she did the context clues for the test, for the exam. So I could go over it. I have to write it down.
So basically it has to be 95% of the data.
Yeah.
So I'm still going to do 95, all 95. We'll see.
Okay.
All right. You take a simple random sample of 100 adults from a town in the western United States to determine the proportion of those in town who invest in the stock market. Assume the unknown population proportion of percentage of people in town who invest in the stock market. I think that would be a one proportion test.
So what is the mean of the distribution?
And how do you do that? I forgot how you do it.
Me too.
It's like I started looking at these like, I forgot. This is not a good sign.
No.
No. Mean of the distribution.
Would this be a one proportion test?
Yeah, 100 adults. I would say it is.
Yeah, it's definitely a proportion test.
So one.
Let's see.
Distribution of the sample proportion is p hat, right?
Yeah.
Yeah.
So it'd be 0.3.
Oh. Yeah.
You mean
I hate when it's so simple.
zero?
I hate it when they're easy.
Just what they gave us right there.
Yeah.
All right, well, don't ask me to do the next one then. I can't figure that one out. All right.
Standard deviation.
I forgot how to do the standard deviations. I have to find that.
It is the square root of p times 1 minus p over n. But we don't know what p is, right?
Are we doing the p? Is the p hat?
I guess we can just do p hat
Try that
since
one.
we don't have p.
Mm-hmm.
Divided by n, p minus 1. What is? Divided by n. Is that what you said?
Yeah, and then take the square root of that. I got 0.046.
Got that too.
Okay.
What is the probability that your random sample of 100 adults will have a sample proportion less than 0.25? Point 0.25 minus 0.3 divided by 100 square root. Oops. How do I find the z-score for this again?
And the z-score?
If they're,
Yeah,
what
so-
did they say, 95%? The beginning? No, they didn't give it.
Yeah, I'm trying to find the z-score so I can type it into the applet probability.
The z-score for a 95% or what percent?
Okay, so true population is 0.3, and what's the probability that your random sample will have a sample portion less than 0.25. Oh, no, I did it wrong. It's 0.25 minus 0.3 divided by our standard deviation, which is 0.046. So negative 0.109. And I have 0.138 percentage.
0. Point what?
0.138.
How did you find that again?
So I got the score of negative 1.087. 1.087. And the percentage I got for that is 0.139. Okay, I'll be right back. I gotta go grab my.
A number, did you guys print out, did you look at the review on the paper, in the lesson?
No, I didn't.
Okay, cool. And I did, and I printed it off, and it gives you 4 different answers to choose from. And the 0.138 on 13 is there. So that's what you said, Lele, right?
Yeah, that's what she said.
Okay. But on
0.138.
the previous one, a number 12, there's no answer like that. So 12 is not the right answer. I mean 13. No, wait a minute.
13.
Yeah. 13, the answers don't even match those answers. So we might have to get, that one is probably wrong.
I'm sorry.
So, I mean, we might need to come back to that one. I don't know how to get it myself.
Sorry, what did I miss?
I was just saying that I printed off the review exam, and on the review exam, it gave you the 4 options, and a number 13, there is no option like that one. So we might want to come back to 13.
Well, if 13 is wrong, then 14 is going to be wrong too.
Okay, well, because on 14 there is that number, 0.138.
What is the standard deviation?
So that's kind of weird that one's right and one's not. I can tell you what the answers are, and so we can plug them in, but
what is wrong with my computer?
For standard deviation, did you do the square root of
my answer?
Times 1 minus 0.25? Bye-bye.
Yeah, so it should be 0.3 times. I don't know my computer. I did 0.3 times 0.7 divided by 100 and then took the square root of that. Is that what you did?
Let me see if I get that.
you did 0.25 minus 0.3, and then the square root of 100.
0.3 times 0.7 divided by 100 and then square root.
So for that, I got 0.065.
Well, we'll just go with it and see if it's right. I'm just wasn't one of the answers on the paper. You want to come back to?
Oh, you got 0.065?
Yeah,
I got 0.046. There's Catherine, 0.065.
No, all the answers are 0.004 or 0.046 or 0.458 or 4.583.
Oh
I
yeah,
had
the
0.046.
Yeah, so the one that we got is on that sheet.
Which one did we?
Yeah, I had 0.046.
You did? Okay, I did it wrong then. You said 0.46? I'm sorry.
0.046.
Okay, you did it right. I heard it wrong. I'm sorry. Apologize.
Oh, it's good.
That's why the other one turned out right.
I've kind of given up and accepted that all these are probably wrong.
Oh, I'm sorry. My it's stupid cold. Okay, we're going back.
Bless your heart. Is it my turn?
Yes.
Okay. The Accupearl is meant to control hypertension. In clinical trials of Accupearl, what is going on with my computer? Subjects were divided into two groups. The 1563 subject group received Accupearl. The 579 subjects in the control group received a placebo. Of the 1563 in the experimental group, 61 experienced dizziness as a side effect. Of the 579 subjects group, 15 experienced dizziness as a side effect. Let P1 be the true proportion of people who experienced dizziness. Let P2 be the true proportion of people who experienced dizziness but did not take it. Okay, so let's pull up our Excel spreadsheets.
So this is the two sample z-test for proportions.
Yeah. Name of the
That's the categorical data analysis hat.
phone. My laptop is about to die, and I left my charger at work. So
This is the categorical or the quantitative one?
you guys want to finish this tomorrow?
I won't be able to.
Okay.
Categorical.
So the two sample t-test.
Freaking gosh, my computer. Frustrating.
I got negative 0.003 on one of them. 0.029.
One is
That's within, and then the margin. I didn't get the margin yet, but I got to divide by 2.
570, so 1563.
So X1 would be 2142, wouldn't it?
Which test are you in, Ross?
I'm in the 2 sample z-test for proportions.
Okay. And you put in
X1,
go ahead, Lily.
X1. 79, right? Hello?
So P1 is the proportion of people who experience dizziness.
Okay, so X1 I got 579. N1 I got 1563. X2 I got 15. N2 I got 579. Is that right?
Um, placebo.
Did I?
Which way are you going? For the confidence interval, I got margin of error. I got 0.027. Oh, hold on.
Lily, what did you say was the X1 and N1?
It says let P1 be the true, the 61.
So P1 is people who experience dizziness while taking, and P2 is
9 and 1563.
that was for 1.
So you got confidence intervals. What did you say? Because I have mine up. I think I put them in wrong.
Sorry, what was that?
My confidence intervals is a negative, on the lower is negative 0.003.
Those were 0.3186. I didn't get a negative confidence interval.
You didn't? So
No.
I put in 61 versus the 1563 in the first 2 boxes.
61?
Yeah, because it's 61.
Yeah, 61 experience
Oh,
dizziness.
you're right. I wrote it in wrong. That's 61. Yeah, I was writing everything in wrong.
And then,
Things.
and then 15.
Why didn't you guys tell me I was?
And then 15 and 579, the other 2.
Yeah. So my new margin of error is. Hold on.
But did you do P one is greater or less or equal what? Not that it
I
matters.
did not equal to. My new margin of error, I got 0.016.
That's what I got.
Lily, pay attention.
Where was the margin of error?
It's not negative.
So you have
Oh, yeah.
to do the whole confidence each other divided by 2 to get the.
Yeah. You divide by 2.
0.016.
Yeah.
Okay.
And then the
Lower bound is 0.03, negative 0.00. Hey, 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 hey. Hey. And then upper bound is 0.029. My computer die.
number 18. Number 18, perform a hypothesis test to see if the proportion of experimental group subjects who did experience dizziness is different than the proportion of control groups who do. The level of significance is 0.5. What are the appropriate null and hypothesis? Go back up there. So if P is low, reject the null. So it would be the first one.
I think it would be the first one.
You think it's the first one?
Yeah, I think so.
Because it's well, it's always the equal on the null, but on the other one it's
Because you want to see. Because I think they're just asking if it's.
different. So they're saying different.
Yeah.
So different is usually that sign with it through it.
Yeah.
Okay. We may have
Alright.
lost Lele for a little bit. Lily.
Yeah, I think so. The value of your test statistic is, I got 1 point, or the test statistic is, that's the Z, right?
Yes. Uh-huh.
So I got 1.458.
Yeah, that's what I got. Okay. P-value of your test is 0.145.
Yeah, that's what I got. Is there sufficient evidence to conclude that the true proportion of people who experience dizziness while taking Acupril is different than the true proportion of people who experience dizziness while not taking Acupril? And the p-value, I think it's greater than, yeah, so it would be,
You failed to reject, right?
yeah, so it'd be, yes, I failed to reject HO.
Okay, yeah, I agree. One of the failed rejects anyway.
Yeah.
Is it fail to reject HO?
So actually so it'd be no, I failed to reject. Because it asks if there's sufficient evidence, but there's insufficient evidence. So it'd be that last one, I think.
Very last one. Okay.
Yeah.
Okay. All right. Oh, great. Okay, so this one I have to put numbers in. Is this the two proportion one, do you think, again? A survey was conducted of 1279 randomly selected adults aged 18 and older. They were asked, are you a morning person or a night person? The hypothesis for this study are age. No, being a morning or evening person is independent of age. Or H, alternative, being a morning or evening person is not independent of age. The results of the survey are given. Conduct a test of independence use the level of significance 0.5. Okay. I think I did this earlier on my other paper, but I think I used
Would this be the chi-square?
yeah, that's what I used the other time. Oops.
All right. Statistic.
Okay.
So the test statistic that I got was 6.579.
Yes. So I got, do we round it up to 6.580 or that's what's
Now
on?
you just keep it at 579.
Okay. 6.579. Okay. Come on, computer. Don't you start acting up. Okay. Calculate the p-value. P-value is 0.087.
Yeah, that's what I got.
Okay.
And should you reject the null or not? Be yes or no. The p-value is greater than 0.05.
Right. We fail to reject. I don't like these yes and no answers.
And
It's horrible. They trick you.
they do.
So if you reject, we're failing to reject. Does that mean yes or no?
For
No.
number 24.
On 24, yeah.
So yeah, for 24, you'd say no. The p-value is greater than 0.05.
Okay.
It's asking if we're rejecting it, and we're not.
Okay. So no means we're not accepting. Okay. All right. Number 25. What do you conclude based on your results? So it's insufficient when we do the other. So what is the difference? What they're saying? I would say the bottom one.
So it's the one that says, I think it's the third one because you have insufficient evidence to say that being, because the null hypothesis is being a morning person or evening person is independent of age.
Right.
And
not
the alternative is that it is not independent.
right. So the one says not independent, one does say. So you're thinking it's the third one still? Even though it says independent, not independent on the bottom?
Is it the alternative that we say is insufficient or sufficient to?
No, it's the no. Right?
So then it would be the third one if it is the null that we're saying is insufficient evidence.
Independent, okay. Okay, that makes sense. Okay, use the following information to answer the next 8 questions. Thanks. We love these. A recent book noted that only 20% of all investment managers outperform the Dow Jones Industrial Average over a 5-year period. A random sample of 200 investment managers that have graduated from one of the top 10 business programs in the country were followed over a 5-year period. 50 of these outperformed the Dow Jones Industrial Average. Let P be the true proportion of investment managers who graduated from one of the top 10 business programs who outperformed the Dow over a 5-year period. Based on the results of the sample, create a 95% confidence interval of P. Input the lower and upper bounds. Okay, so which test are you thinking we'd use?
I'm thinking it's the one proportion.
And so do we put in 0.2? No. No, you just do 50, or was the number? So one of them is 200.
Yeah, I think N is 200.
50 of these. Okay, so 50 and 200.
Oh, yeah, 50.
Okay, 200.
And I think the null hypothesis is 0.20.
And is the confidence level 95? Yes.
Yeah.
And is it greater or? Or equal to? I think it's equal, don't you? Not equal to?
Yeah, I think so.
That's what I'm thinking. Okay, I got, for the lower bound, my answer would be 0.190.
Yeah, that's what I got. Upper bound is 0.310.
Okay, 28. Suppose you had been in charge of designing the study. What sample size would needed to construct a margin error of 2% with a 95% confidence interval? Use the prior estimate of P equals 0.2 for this estimate. I'm a little confused on what I'm going to do with that one.
So
Is that this? We just did a 0.2 though.
So it says, I'm just looking at a recap of a lesson. It says we can determine the sample size we need to obtain a desired margin of error using the formula N equals Z divided by that margin of error squared times P times 1 minus P. So Z is
1.96.
1.96.
Yeah. So margin of error is?
So we want equals that divided by, and the margin of error is 2%.
Yes.
So that would be 0.02. that, that, then equals that times 2. Times 1 minus 0.2. All right. I got 1,536.640.
We're supposed to round to the 1537, I think.
I don't know. It doesn't say to, so I'm just not going to.
Okay, tell me that. What did you get again?
I got 1,536.640.
Okay, because I always thought with the sample size you had to round up. I don't know.
Yeah, that's usually how it is, but I don't know. It usually tells us to round up if it wants us to.
That's true.
Because, yeah, in the instructions it says round to 3 unless otherwise directed.
Okay. Sounds fine.
Did you get the email from Lily?
I did not. I didn't just check. What'd she say?
She asked you what your phone number is. She wants to call in.
She wants. I'll just call her on my landline.
I made it.
Oh,
I'm back.
sorry. I didn't know. I didn't get your message.
No, you're good. I just figured out how to do it on my phone. My husband's computer sucks. I'm sorry, guys. What did I miss?
Well, we'll just.
We just
Can
got finished with 28.
Oh my gosh, you're killing it. Can I get number 16? It didn't save it before my computer died.
Yeah. Negative 0.003.
Okay, that was the lower bound. Is it okay if I run through?
Yep. It's fine.
He was. Okay. Perform a hypothesis test. So for 18, null, the alternative hypothesis would be.
We thought it was the first one. Do you agree with that?
Okay, perfect. Yeah. What did you get for the test statistic?
1.458.
Okay, and the p-value?
0.145.
Okay.
Anything I'm wrong, Ross, remind me, okay?
What did you decide? Was there significant nod, and you kept the null hypothesis, right?
We did the bottom one. No, failed to reject.
Okay, perfect. Hey, get off of there. Kid. Okay. And then survey. Okay. What did you get for 22?
6.579.
Hey, stop it. 579. 23 for your p-value?
0.087.
24.
Yes, the p-value is greater than 0.505.
I actually got
Okay.
no.
You got no on that one?
Greater. Yeah, because you're failing to reject it.
Okay, so no, the third one, the fourth one.
Yeah.
No, the p-value is greater than 0.05. That makes sense.
All right, thank you. The
25.
third one.
We have insufficient evidence to say that independent of age. A recent book. Okay, lower bound.
0.190.
And upper bound.
0.310.
Okay, and you said you're on 28?
We just finished it.
Oh, okay.
Ross came up with the answer 1536.640. But I didn't know if we were supposed to round up, but we decided not to.
Probably round up, yeah, to a whole number.
That's what I was thinking.
Yeah, we were just not sure because usually she tells us to or not. But usually sample sizes are rounded up.
So you got 1537. That's a huge sample.
Yeah.
1,500. Stop eating my headphones. Thank you. I can take the next one. Suppose you wish to see if there's evidence that graduates of one of the top 10 business programs perform better than other investment managers. Test using significance level of 0.05. Can you let go? Can you let go? Okay. Would it be the 1, 2, 3, 4, the fifth one?
That's what I was thinking.
Yeah, I think so.
Okay. Yay! Good job.
What requirements must be met to ensure that p-hat is normally distributed? So it is the first one.
Yeah.
That's what I say, yes. All right, I don't know what test statistic we're talking about now. And what information am I taking?
It would be the one sample.
Yeah, it's that one we were doing before with the 200.
Okay. Test statistic is 1.768.
That's what I got.
Okay.
I actually don't have the Excel spreadsheet downloaded on this computer, so I can't do the next one.
Okay, I got it. P-value of the test is 0.077.
That's what I got.
Okay. Is there sufficient evidence to conclude that graduates perform better? What was the significance level? 0.05?
Yes.
So I say no, fail to reject the null hypothesis. No, I failed. Yeah, no, fail to reject the null hypothesis. The last one.
Last one. what I got.
Use the following information. That's the long one.
Oh,
Computer software is commonly used to translate text from one language to another. Part of his PhD thesis, Philip Cohen developed a phrase-based translation program called Pharo. Quality of the translation can vary. A good translation system should match a professional human translation. It is important to be able to quantify how good the translations produced by Pharo are. The IBM Research Center developed methods to measure the quality of a translation from one language to another. One of these is the bilingual evaluation under study. This score is numbered ranging from 0 to 1. It indicates how well a computer translation matches a professional human translation of the same text. Higher scores indicate a better match. Blue helps companies who develop translation software to monitor the effect of daily changes to their systems in order to weed out bad ideas from good ones. Okay, so compare Pharo's ability to translate with similar computer translation software. Cohen took a random sample of 100 blocks of Spanish text, each of which contained 300 sentences, and used Pharo to translate each of these into English. The blue score was calculated for each of the 100 blocks. These scores are recorded in this place. He wants us to use this data to see his mean scores differ from the mean score of another leading translation software, which has population mean of 0.295. Assuming the requirements are satisfied, construct a 95% confidence interval for Pharo's true mean. Record your answers below. Okay. That's a lot.
that was a lot of reading.
It's like, all right, so where's the blue one?
What type of test should we use for this one?
Well, there's comparing the two. No. It was just one, isn't it? Because there's only one row of data on the spreadsheet. So I'm thinking it's just the one of the. Is there one sample t-test? What do you think?
Yes. It's quantitative, not categorical, right?
Uh-huh.
Yeah.
Okay.
One sample t-test?
Yes, that's what I'm going to go for. I'm just copying and pasting this long 100 thing.
Okay, I am just trying to download the Excel sheet.
Okay. So what I got, the lower bound was 0.282. Is that what you got?
Yeah, that's what I got.
0.282?
Uh-huh.
Yeah.
Okay.
The upper bound, I got 0.293.
Yeah.
What did you get, Ross? Sorry.
0.293.
Okay.
So the degrees of freedom.
That'd be 99.
Yep. 99.
What'd you get for the degrees of freedom?
99.
Okay.
The test statistic is negative 3683.938. Is that what you got, Ross?
What was that?
Negative 3683.938. We're big.
That seems really high for a test statistic.
It does.
3.938.
Is the null hypothesis 0.295?
Oh, I didn't change that. 0.295. I didn't change that part. Thank you. That's a lot better.
Yeah.
Thank you, Ross. It was like,
Yeah.
what? Okay, so negative 2.803.
803. 2.
Yes.
Okay.
And
Oh boy. Sorry, I'm not more help right now.
that's all right. The p-value for that is 0.003.
That's a little p-value.
Or
That's what I got.
So,
What's
since that's smaller, what's that?
is the type of test it's not equal to. So the p-value would actually be 0.006.
Not equal to?
0.006, which
Okay.
is still smaller than the significance level. Then we would say the first one, right? We have sufficient evidence to say the true mean is different than 0.295.
So for these, do you say that we have sufficient evidence against the alternative?
We have insufficient to reject the null hypothesis, or we have sufficient evidence to accept the alternative hypothesis, right? Am I wrong?
No, I think you're right. I just had to think how that was going down.
Okay.
Because so the first one,
Yeah, I think so.
is that another long one? Okay. A study was done to test the notion that people are taller when they first wake up in the morning and in the evening right before they go to bed. To test this theory, the heights of children in a boarding school in India were measured. Values were recorded in millimeters for each child in the morning and again in the evening. Data is recorded in this. You want to determine if the children are taller in the morning than in the evening. Define the differences as AM height minus PM height. Construct a 95% confidence interval for the true mean difference of heights and conduct a hypothesis test of 0.5 to determine if the children are taller in the morning than in the evening. Input your answers below. Okay. So this is a two-test paired sample because they're the same person being tested, right?
Yeah.
Okay. And so is the null hypothesis 0, or am I changing that?
What's that?
The null hypothesis isn't 1, right? I don't have anything in that box for the null. Because it's in that, and so is the type of test not equal to, right?
Yeah.
or greater than?
Let's see.
They want to know if they're taller in the morning than in the evening.
Yep. Yeah. So greater than.
Okay. All right, machine, come on. Okay, so the lower bound, what I got is 8.728.
Yeah, that's what I got.
8.728.
Yes.
Alrighty. And then the upper bound.
That I got 10.455.
Yeah, that's what I got.
10.455.
Okay, number 42, input the test statistic. That is 22.446. Is that what you got, Ross?
Yeah.
These numbers seem really high.
They are.
What's the degrees of freedom?
It's 40.
Yeah.
40.
Yes.
Okay.
And the p-value is 1.397.
What is the E negative 24 at the end?
Oh, so it'd be 0.
Yeah, there's got to be something wrong with the numbers we put in. So let's see.
Would this be a two-sample t-test?
I think this would be one of those ones where they subtract the first number from the second number.
Yeah, that's what we did. That's the pair.
And did you clear out all the numbers from the last test?
Yeah.
Well, we've both got the same numbers, so.
Okay, so what did you get for the p-value? Basically 0?
Yeah.
Yeah.
All right.
Good thing we have another shot.
Is there enough evidence to suggest that the children are taller in the morning than in the evening? That'd be no, because we reject the null.
We failed to reject the null. Right? Yes or no?
No, the
Because we
p-value is
rejected the null.
smaller.
Yeah.
It's low, we reject the null.
All right.
Time to submit, try, give it a shot. Scary time.
Scary.
Like, oh dear.
How'd we do?
Well,
We missed number 2,
yep.
7, 9, 11. Woo.
Sweet.
We got 35 out of 43.
Not bad. Were the last ones right?
The
The very last
last
one.
one was wrong.
45 was wrong. probably was the fail to reject. But the other numbers were right.
I wonder if it was yes, we reject. Because we would have to reject it since it's
Yeah,
less than the confidence interval.
yeah, I bet it is. So,
Yeah, that makes sense.
and then, let's see.
So we missed number 2.
Number 2.
All right, let me get back up there.
Holy cow, all this scrolling to the top.
It's one of those ones again about the test of guessing what kind of test it is. Number 2, where are you? I've got number 6.
Could it be ANOVA? No, because there's only 2.
Yeah.
But maybe it was the paired samples after all.
All right, let's try that one.
And then number 3 was right.
Hey, Lele, have you submitted yet?
Nope.
Okay, well, good. Then you can change. You will know what they're right or wrong.
Yep.
Number 4 was right. Number 5 was right.
Yeah.
Number 6 was right.
Hey, we did good.
Number 7, not.
Yeah, 7's wrong.
So, in a Wall Street Journal article, career paths. Oh, this is the 2 different majors.
I think this is a confidence interval for 2 proportions because we're finding the percentage of people who are satisfied.
That makes sense.
Okay. How do we do it?
Number 8 we got right. Number 9 was wrong.
Oh, really?
Yeah.
The probability for rejecting?
Yeah.
There must be the type 1 or type 2 error, type 1 errors or something. Because it's not the other one, because we got the other one right, and it repeated the same thing. So type 1 error,
Yeah.
see what a type 1 error is. What is it?
If we have a small significance, then that's the probability of a type 1 error. Yeah.
So it'd be a type 1 error.
Yeah.
Okay. So we got 10 right. 11 was wrong with the 95% of the data.
I got
Did you get
mine
that
was
one right?
right. Mine was right on that one.
So it was 95% of
What?
all.
Yeah.
95% of all 95 count. That's awesome.
Yeah.
Okay. What
12
else we
was
got?
right. 13 was right. 14 was right. 15 was right. 16 was right. 17 is right. 18 is right. 19 is right. 20 is right. 21 was right. 22 was right. 23 was right. 24 is right. 25 was wrong. So that would be the bottom one instead.
Okay.
26 was right. 27 was right. 28 was right. 29 was right. 30 was right. 31 is right.
What did you get for 31?
1.768.
Okay, I'll make sure I got that. Okay.
32 was wrong.
Yeah, we got it off the same paper.
What'd you get for 32?
0.077.
That's what it shows on the paper. And the test statistic was right. Everything else was right. If we change the
wonder-
other one,
The type of test, if it's greater than or
yeah, greater than, it changes
Yeah.
the value to 0.
what did we put on that?
You want to see if the graduates have a greater score than the normal.
Okay, then the greater than one is 0.039.
What? I'm sorry. What was the new answer?
0.039.
Yeah.
That's probably it.
All right.
That changes.
33. We also got wrong, but that's because that was wrong. So we would actually be rejecting.
So yes, I rejected the null hypothesis. So the first one.
Yeah.
The first one, okay.
34. We got right. 35 was right. 36 is right. 37 is right. 38 is right. 39 is right. 40 is right. 41 is right. 42 is right. 43 is right. 44 is right. And 45 was wrong.
What did we change 45 to? Yes, because we rejected the null hypothesis.
Yeah.
Yeah.
Just making sure. I'm going to go ahead and submit.
Okay.
It's take a while because this computer is slow.
So what are you doing for Thanksgiving?
We're gonna go to our cousin's house just a couple miles down the road, so that'll be fun. I think it's our first Thanksgiving not like traveling, so that's nice.
Normally you go see family, other family?
Yeah. Yeah, we're a pretty popular commodity, so we go visit everyone.
Especially when you have a baby, you know, everyone loves to see the baby.
Yeah, exactly. And he just gets more and more fun, so they all want to hang out with him. Oh my goodness, this is still loading. Oh, I got the text message with my score for before. It's not even close to finish loading, but I have the text message with the score. Ah.
What are you doing, Ross?
I'm just staying here, going over to my family's house and just kind of hang out over there with them.
That'd be nice.
Yeah. How about you?
No, my son and daughter probably come over with their kids.
Awesome.
Won't have to work.
Nice.
That'd be nice. Yeah.
Those jobs, though. All right, let's see. So we still got number 2 wrong.
Would 2 be a chi-squared test?
I don't even know what that is, to be honest. 2 and 22.
We had 22 wrong?
Yeah.
Number 22? I don't remember that one being wrong.
Maybe I did that wrong. I have 6, 5, 7, 9.
Yeah, it'd be 6.57 then.
Oh, I just 6.579?
Yeah, 6.579.
Let me double check. I might have just typed it in wrong. Yeah, I put a comma instead of a period. Whatever. And 2, we decided was the chi test because we don't know what it is, so that must be it.
But isn't chi more than 2 tests? Whatever. Maybe, no.
The reason why I think it might be chi is because so it compares the education level. So there's high school, undergraduate degree, master's degree, doctoral degree.
Oh.
So there's 4 things right there.
Oh.
It's either.
So would it be chi or would it be ANOVA?
Yeah, that's what I was wondering.
Okay. I think it's not a proportion, so it would be the chi test or the ANOVA test, right?
I think so, because it's not a proportion. Was that the only one we missed?
What was that?
Was that the only one we missed?
Yeah, 2 and 22.
Awesome.
Awesome. All right. All right.
I'm
Happy
submitting.
Thanksgiving to you all.
Yes, you too.
See you on Monday.
Yes, see you
Yes.
on Monday.
Thank you.
Okay, see ya. Bye, guys.
Bye-bye.
See ya.